Hi everyone, how are you doing? Can you just confirm if audio, video, everything is fine? Okay, once you confirm if everything is fine, then we will just start. Okay, so let me just know if everything is fine, and then we will just start with the session. Okay, so there has been AIMT, and now we will be basically solving the part 2. Okay, we will be having the part 2, right? So just let me know if everything is fine. Okay, seems like everything is good, right? I've also cross verified it. Okay, great. So now let's just get started with this part. So what they're saying, let's just start with the questions. So in the remaining questions, mostly I think all of these questions are basically 2 marks. Okay, so whatever we will be solving today, all of these questions will be of 2 marks, right? So let's just see these questions very nicely. We will solve these questions, and we will be having the detailed video solution, right? So which means that we will be solving each and every aspect of the question. So let's just see what this question is saying. By the way, this question is related to soft SVM. So how many of you know about the soft SVM? Okay, so we have already seen soft SVM in the class. So probably you might be knowing about it, right? So now basically they are asking that in this particular case, let's suppose this particular question is given, then which basically which C is higher, CA, CB or CC? So what is your answer for this particular question? See, let me just remind you that for the soft SVM, this is the formulation, right? So here you have the select variables, and here this is how it looks like, right? So this is the formulation of soft SVM. Now they're asking that basically in this question they're asking, ultimately in this question they're asking that what is the impact of C, right? If we increase this C, then what is the impact? Okay, so for example, that we have seen, this is the slide from the this is a screenshot, or this is a slide from the lecture. So in this particular slide we have seen already that what happens if you keep on increasing the C, right? For example, if C is smaller, let's suppose C is 0.01, then typically this is the boundary that you are getting, and in between this there could be many other points, right? If C is larger, then this is the margin. If C is larger, if even more larger, then this will be the margin. And if C is very very large, then the margin basically your support vectors will not be misclassified. Basically C is controlling, right? C is controlling the slack, that how much slack you can tolerate, right? Controlling slack that we can tolerate, right? So if C is large, then we will be tolerating less slack, right? If C is large, then in this margin there will be less, you can say less number of points will be falling, right? If C is smaller, then it is allowing more points to fall, right? To fall. So basically if C is small, then it is actually favorable case, right? If C larger, then it is as good as hard margin, and obviously we don't want to go to the hard margin, because hard margin is separate. We want to take use of the soft margin, right? So we will be typically keeping the C large, and will be basically allowing the some slacks. So sorry, C small. So C small means we are allowing some slacks, right? So here, if this is the boundary, right? This is the boundary. It means that if you check that, yes, we are allowing these two slacks, right? These two are slacks. So we are allowing these two even misclassified, right? So this C is allowing some slack, which means this CC should be smallest, right? CC should be smallest. Is this fine to everyone? Let me know if there is any problem in this. Okay, so the CC should be smallest. So this is how you can understand about this particular problem. And now let's just see what about others. So in this particular CB, in this particular case, what we are doing, well, we are allowing, so basically this is correctly classified, and this is within the margin. Okay, this is coming within the margin. So it means that we are still allowing some slack, but not much. So it means that CB might be larger. And then CA means that this is here we are not allowing at least any slack, right? These two are correctly classified, and these two are so basically, sorry, this is the margin, right? In case of A, this is the hyperplane, right? In case of A, we are not allowing any slack, right? Yes, this is misclassified, which is okay, but at least we are minimizing the number of slacks, right? It means the CA must be highest. Okay, CA must be highest. Why? We are at least minimizing the number of slacks. So if we are very much caring about the slacks, right? If we are very much caring about the slacks, then C must be higher, right? If we don't want to have any slack. So this A is saying that I'm very much caring about the slack, right? So which means CA must be highest. Have you seen this question? I mean, some this kind of question in the test series also, in the subject wise test also. Have you seen this question in subject wise or topic wise test? Have you seen? Let me know. There was a question, right? You might remember in SVM itself. There was a topic wise test in SVM. Maybe I currently, maybe it will be a little hard for me to find out that particular question. But yeah, in the test itself, in the topic wise test, there was a question which was related to this only, right? I mean, almost like this. Do you remember? Okay. So we have already seen such things in the topic wise test also. Now let's just see this particular question. This was also a nice question. It was MSQ question. Okay, multiple select means it was MSQ question. So now let's just see what this question is saying. But before that, let me know if there is any doubt in that particular question that we have just solved. Okay, is there any doubt in that particular question? Okay, okay, great. Now let's just solve the next question, right? Okay, now let's just solve the next question. Yes, similar question in SVM topic wise. So some people are saying the same thing. The similar question in SVM topic wise. Okay. Okay. So Faiz Khan is saying this are only 44 number. So see, 44 is not only, okay. 44 is very good number. Okay, 44 is very good marks, to be honest, right? So it's not only marks, it is very good marks. There might be few mistakes that you might have done, and you just need to rectify those mistakes. So Faiz Khan, are you Go classes enrolled student? I mean, I'm just asking you because maybe few of the things you might not have studied, in any other coaching. So that is the reason I'm asking you. So are you Go classes enrolled student? In that case, if you're Go classes enrolled student, in that case, the strategy that I will suggest you to revise with the annotated notes. Okay, you should revise with the annotated notes. Just see all the annotated notes that you have already covered as a lecture. Now you can revise with the annotated notes, and now once a revision is done, then this 44 could be 60 very soon. Okay, it could be 60 very soon. This 44 will be 60 very soon. Okay, so just a little bit revision is needed. So as I already told that, see, this particular test is not for testing your knowledge. It is just making sure that you are basically very much familiar with the exam temperament, right? The 3 hours. Okay, for those 3 hours you should be comfortable. So since this is the first AIMT, we will be having more AIMT, you will be more comfortable, right? So you can increase your marks in the further AIMTs, and never actually worry about the marks, because in the AIMTs, some questions could be tough or easy, but once you have the proper analysis of the AIMT and all, then your basically preparation will be so strong that in the gate examination you will be getting the decent rank. And that is our aim, right? In gate examination we want to get decent rank. So keep on attempting AIMTs. Yes, so that is the thing, right? That KK is saying काफी अच्छे questions थे. Thank you so much. So thank you so much, KK. Okay, so let's see this question. What this question is saying: after gradient descent update, the objective function value at the weight vector is always lower after update than before. Is this true? So they are saying the objective function value is always lower. See, the thing here is that, let's suppose this is the function, and then you are applying the gradient descent, but it might so happen your step size is so large that you end up going here, right? Because of your step size, it depends on the step size. For typically small step size, this statement could be true, but obviously small is not quantitative. We can't just say small like that. I mean, we can always argue what do you mean by small. But yeah, if they are saying that, okay, the objective function, see here the objective function, let's suppose this is the objective function, here the objective function value is, let's suppose 3, but here it could be 10, right? Here it could be 10. So after one update, the value can increase, right? After update, the value can increase if the if step size is larger, right? So that is why this statement is false. Is this okay to everyone? That is why this statement is false, right? Yes. So Faiz Khan is saying, sir, maza aa gaya. Yeah, thank you so much, Faiz Khan. Faizan Khan, sorry. Okay, sorry, I think I'm mispronouncing your name, but yeah, this is he's Faizan Khan. So let's just see option this B. What they're saying, there's always a unique steepest descent direction in the gradient descent. Is this true? Do you remember I told this particular, about this particular option B in calculus lectures? How many of you remember from the calculus lectures? I told about this option B. So this is actually false, right? This is false. Why? See, consider a case. What is the steepest descent direction? Can anyone tell me? Which one is steepest descent direction? Which one? Tell me. See, if you have in the direction, if you have grad f, right, minus grad f, if you have minus grad f, then this is the direction where your function will be most decreasing, right? So direction where, I mean, it will be evaluated on some point. Let's suppose you are saying at point number x naught, right? I mean, it will be evaluated on some point. Obviously, like this grad f is a vector here, right? This will be a vector, maybe x square minus y, x plus z minus z, something like this, right? Grad f will be a vector. You have to put x, y, z value to get the direction, right? Something, okay, 3, 5, 9, whatever, right? It will depend on a point. At every point, the grad f is changing. Okay, at every point the direction, the grad f magnitude and grad f direction could be changing. So at that particular point, okay, at that particular point grad f will be, something like this, okay, something like this, okay. I mean, it will be in numerical form, right? So if you are, let's suppose if you are standing at this point, right, if you are standing at this point and you ask me where to go, there are multiple directions, right? There are multiple directions where to go such that my function will be most decreasing, okay, or steepest decreasing, right, or steepest descent direction. There are many directions possible. So you will say, find out the grad at this particular point, right? Find out the grad at this particular point, okay, whatever the grad is coming, okay. Let's suppose this point is x1, okay, let's suppose this point is x1. So whatever grad is coming, maybe it is 1, 2, 1 minus 2, and let's suppose 0, okay, this is the grad, okay, or maybe it is 1 minus 2 and 5, okay. Then let's suppose 1 minus 2, 5 is this direction, okay. Let's suppose 1 minus 2, 5 is this direction, right? Then you will say that, okay, this is, I mean, this is the vector 1 minus 2, 5. So you will say, okay, this vector is like this, right? Now along with this, if you go, right, along with this, if you go, then you will be seeing the most decreasing or steepest descent, right? Now tell me, can there be multiple possible directions? Yes, I already told in the calculus lectures. How many of you remember that in the calculus lecture I already told about the option B? How many of you remember? Just let me know quickly. Okay, so some of you might remember this, right? Some of you might remember that in the calculus lecture I already talked about this particular option. Now so what they are saying, that do you have multiple steepest descent? The answer is, it is possible actually. If you are having one of the component is 0, so it means that see, it means that you go, for example, you go plus, I mean, one direction here, minus 2, let's suppose is this, and then 0 in the z direction, okay. In the z direction, either you go, see, for example, let's suppose this is one direction, okay, I mean, this is 1D, okay, I mean, let's suppose along this direction grad is 0, okay. So maybe along this direction, along the y direction and along the z direction, there is some grad, okay. But along this x direction, suppose the grad is 0, okay, which means my grad at that particular point in time, okay, I mean, let's suppose this is your graph, okay, this is your plot. At that particular point, at this particular point, the grad of f, okay, grad of f looks like this, 0, -1, 3, something like this, right? Then you will say that in bi direction you go negative, -1, in z direction you go 3, which is maybe, I mean, I cannot draw this because it is 3D. Okay, but yeah, let's just try to draw it. Okay, in z direction you go, I mean, z direction will be how I should be representing. Okay. Let's suppose here you go 3, here you go 1, but in x direction, how much to go, right? Or are you going, I mean, how much is not a not an issue because it is just a direction, not the magnitude. But yeah, are you going the left in the z direction or you're going the right in the z direction, right? So there both possibilities are open. Okay, so here you can say two directions are possible, where steepest descent will be happening, right? How? Because in y and z the things are fixed, but in x whether to go left or whether to go right, it is not fixed because the grade is 0. I mean, actually it won't matter. Okay, so here two directions are possible where steepest descent, these both of these directions will be steepest descent directions. Understood? Understood? Yes. Yes. Okay, so basically now let's suppose if you say grad f is 0 0 and then 3, then how many possible directions? In z it is fixed, but here you have two possible directions, here you have two possible directions, so you can say 2 into 2, 4 possible directions, right? In 4 possible directions, all of these 4 possible directions, you will say all of these 4 possible directions will be steepest descent. Okay, all of these 4 possible directions will be steepest. Okay, I hope you understood this. Right, now is this unique? Then answer is no. Okay, this is false. We have talked about this in calculus. Okay, so maybe you can recall, right? Now let's just see this option C. What they are saying, gradient descent converges to optimal solution for the logistic regression under the appropriate assumptions. So yes, that is true, right? So do you know the logistic regression have convex function? Okay, convex, right? Appropriate assumption means that learning rate is not like that you're fluctuating or like that, like, right? I mean, all of this is coming under appropriate assumptions. But yes, basically they are saying that it will converge to globally optimal solution for logistic regression. So since the logistic regression loss, okay, I don't have plot with me currently, but yeah, that is a convex function. Okay, the logistic regression loss. So what do you mean by convex function? It means, convex function basically means that you have unique minima. Okay, not unique, basically, I mean, convex function doesn't necessarily mean unique minima, because this is also the convex function, right? There are multiple minimas are possible, but convex function means the local minima is same as global minima. Okay, this is what convex function means. So yes, basically gradient descent will obviously, since there is only local, I mean, all the minimas are global minima basically, so you will definitely end up in the global minima. I mean, there is no chance of local minima because local and global are same. Okay, so that is why this is true. What about this? Since ReLU is a convex function, okay, the neural network that uses ReLU activation is also the convex function, and therefore gradient descent will be converging to the globally optimal solution for the neural network with the ReLU. Okay, so what do you think? See, they are saying the ReLU is a convex function. Okay, what is the ReLU? Maximum of 0 comma x, right? See, is this a convex function? See, if you try to plot it, if x is negative then it is 0, if x is positive then it is like this. Yes, it is a convex function, right? I mean, it is basically bowl shape, right? It is a convex function. So ReLU is a convex function. This is a ReLU. But they are saying that any neural network which is using ReLU will always give you the global optimum. No, see, if you are using ReLU, right? See, if you are using, let's suppose this is your neuron, and then you are using ReLU here, right? Now, what may so happen that see, you now after that you have to apply basically, sorry, not ReLU here. You are using ReLU here, right? After this you have to basically pass it through, let's suppose some other neuron, right? But it is definitely possible that it depends on this weight, right? It is definitely possible. What is the weight of this? So let's suppose this is negative, right? So whatever you are getting here, right, whatever you are getting here, let's suppose you are getting x, okay, then it will be minus x. You will be getting minus x here. Is this minus x convex function? See, if you, this is very simple, that if you, even if you put negative sign, then this particular final resultant will not be a convex function, right? So they are saying that if you are using ReLU, then you will always get the global optimum solution, right? So which means, I mean, it is actually not necessary that obviously and then otherwise the all the neural networks will be having, all the neural networks will be having the convex functions, right? Just using ReLU in the neural network doesn't necessarily mean that finally you will be getting the convex function only, because ReLU plus linear functions, it is a complicated, final function is very complicated, right? The final function need not to be convex. Okay, so that is why this is false. So let me know if that is little bit understood or not. Okay, so probably you're getting little bit, right? So see, the final function could be very complex. This is what I'm saying, right? The final function could be very complex. So what is the final answer of this particular question? Yes. So the answer of this question is just C, right? Even though it was a multiple select question, it still only C is the answer. Okay, it still only C is the answer. So it was a nice question. By the way, this question I think I've taken from Stanford or Berkeley. I don't exactly remember. Maybe I'm having the link, but that's not worth to paste the links and all. But yes, this question was from Berkeley. I just checked it. Okay. So now let's just go to the next question. Okay. So let's see this question. This question was also very nice. Okay. So someone is asking, I have confusion in C. What is the confusion? Logistic regression loss is different. Okay. Logistic regression loss is cross entropy loss. Okay, that is not a sigmoid function. Logistic is using the sigmoid function. That is for sure. I mean, logistic uses the sigmoid function, which is basically something like this. Okay, so it will be using the sigmoid function, but finally it will be the cross entropy loss, or the objective function will be cross entropy loss. Just revise your notes and then you will be understanding that yes, logistic regression is basically giving the probabilities using the sigmoid, but ultimately it will be the cross entropy loss, right? Okay. And is sigmoid a convex function? Tell me, is sigmoid a convex function? I think in this particular test only we have asked the same question. Is sigmoid a convex function? Obviously, sigmoid itself is not a convex function, right? Even though you have sigmoid, let me just plot the graph of sigmoid. So this itself is not a convex function, right? How? See here. So sometimes it is up, sometimes it is down. So we want always up. This line should be always up, right? So this is not a convex function. Now let's just move to the next question. So let's see this question. This is question number 48. This question was a nice question. How many of you were able to solve this question? Let me know. Okay, so this question was saying, it was, by the way, multiple select, again MSQ question, right? It was MSQ question. So they are saying that you have your data set. Okay, you partition this data set into ABC. Okay, I mean you have partitioned the data set into ABC. You're training 3 models and all of the models are trained on A. Okay, so you're training 3 models, X, Y, Z. So tell me, what is the train set? This A is a train set for all, right? It is a train set. B and C might be for some other purpose, but yeah, A is a train set, right? Now X, Y, Z, they're saying that they're differing. Only difference is that lambda is used. Okay, I mean they're all are using some same regularization, which is L2. Now lambda value could be here 1, it could be 0, it could be 2, or anything. Okay, I mean they have not given in the question that what should be the lambda value and what is the lambda value, but what they're saying is that the difference is basically only the lambda values, right? Only difference is that lambda is being used. Now this is the MSQ question. Okay, this is a nice question. How many of you were able to solve it correctly? Tell me. Okay. Sure. Okay. So फैज खान is saying, सर कुछ डाउट है लास्ट में बता देना. हाँ, definitely. Okay, I will just complete the session and I will just take your doubts if it is non-technical. Okay, so let's see option number A. Suppose Z has lowest average loss on B. Now they are saying that B and C are being used for some other purpose, and now they are saying that Z is having the lowest average. I mean lowest mean is, I mean you don't worry about the average, either you take the average or don't take the average, doesn't matter. But yes, they are saying that Z is having just sort it, I mean everything on the same page. Yes, okay, I think you can see everything on the same page, right? Okay, so now they are saying Z is having lowest error or lowest loss on this B. B is some test set. I mean, you don't worry about the B. They are saying, okay, if you evaluate on B, it will be having lowest, okay, among this X and Y, X by Z, among the all. And then Z will also be having lowest on C. No, right? I mean, there is no relation like this, right? I mean, it is possible that Z is having highest on C. Okay, it is even possible that Z is having highest on C. Is there any relation? If Z could be the better model, right? I'm not denying on this. Z could be the better model, which is, let's suppose, giving the lowest on B. Okay, could be the better model, but C could be such that on this particular data set, okay, in this particular data set, it could be such that it is giving lowest on X. I mean, it can be anything, like distribution of the C and distribution of B could be anything, right? It depends on the data set to data set. The exact values depend on the data set to data set. Okay, most likely it should happen. Okay, most likely if Z is giving lower error on B, most probably it should happen, it should give lower error on C also. Okay, in practical scenarios. But this is a theoretical question. Is this always going to happen? Then answer is no, right? It need not to be. It depends on the distribution of C. So that's why it is false. Let me know if that is okay to everyone or not. Okay, let me know if that is okay. Okay, now let's just see this. If A and B have exact same exact mean and variance, the average loss of model Y on B will be exactly equal to average loss. So basically they are saying A and B is basically having same mean and same variance. Okay, these are the two data sets which are basically following same mean, same variance, something like this. Okay, A and B are looking same in terms of the mean and variance, right? But it is definitely possible that the data sets could be different, right? I mean, the mean and variance, having the same mean and same variance doesn't mean that the data set will also be same, right? So probably I can just tell you something like this. Maybe see, this is the data set which is, let's suppose, A. Okay, this is a data set which is A. Okay, this is x1, x2 are the two features, right? And this is a data set which is B. Okay, this is a data set which is B. Okay, where x1, x2 are two features. Are A and B two data sets same? Okay, tell me. See, if we have something like this. Okay, if we have something like this, let's suppose, let's just have 3 points for the sake of easier x1 easier explanation. Okay, and then here you have B. So if you calculate mean and variance, it will be same actually. Okay, the covariance and these things could be different, but yes, mean and variance of A, mean of A is same as mean of B. I mean, the average is anyway 0, right? Average is anyway 0. So mean of A is same as mean of B. And similarly, if you calculate that variance, right? Variance will also be same, right? But the data sets could be different. That's what I'm saying. Data sets could be different. So they are saying that A and B are having mean and variance same. Actually, this information is not relevant. I mean, this information is not telling us anything, right? Then they are saying loss of Y will be also same on whatever it is on A. It is same on B. No, A is a train set, right? A is a train set. B could be the test set, which is very different from A. A and B could be very different, although their mean and variance are same. Mean variance same doesn't mean that they both are same, right? Okay, the data set itself, I mean, just two numbers can't capture this much information that okay, data sets are exactly same, right? Just two numbers, mean and variance, can't capture that much information. That is the thing, right? So basically these two, I mean, this information is not very relevant. Okay, I mean, it is not doing anything. So this is a train set that they're in other words, they're just asking that the loss on the train set and the loss on the test set are same. Obviously no, right? Obviously no. So that is why this is false. Okay, so this is false, this is false. It was MSQ question. Let's just see C is true or not. Okay, so let's just see what what this option is saying. Option C is saying, let me go to the next page. and let me just tell you what this option C and D are saying, right? Okay, so option C is saying that you are having lambda equal to 0 for x. So loss of x on A and loss of y on A. Okay, so they're talking about only A. So basically they are saying you have divided, right? You have divided into A, B, C, and now X, Y, Z are there. X, Y, Z are three models which are trend here. Now they are saying this is having lambda equal to 0. Okay, again, this was a nice question. How many of you were able to solve it? See, if lambda equal to 0 is there, then we have seen, right? We have seen test loss might be, might be less, but train loss will be more. Basically, W into W lambda into W transpose W. This term is not there for X, right? I mean, there will be loss. I mean, there could be mean square loss or something, right? There will be loss, and then there will be a regularization term. But for X, this term itself is not there. If this term itself, the whole term is not there, then the train loss will be lesser. Okay, because train loss is regularized one. Test loss is not regularized one. Okay, test loss is just LW. This is important. Train loss is always regularized one, right? Train loss, which means with regularization. Test loss is never with regularization. Okay, you don't add this term. This is unnecessary in test loss. Why you will be adding this term? I mean, this is up to, see, this is up to you, right? You have basically modeled it in such a way that you are regularizing. But as a tester or as a, as a model evaluator, you will be having the MSE. You will not be having the regularization term, right? I mean, whatever method you did to optimize your loss function, that is up to you. But I will be not using these things, right? I will be using just like plain vanilla mean square error. Okay. Okay. So by the way, how many of you were able to relate this with the class questions, or with the? I think I'm not. I think I'm 100% sure. In the class also, we have solved the similar question, but not with the exact wording. Okay, the wording was not exactly like this. The wording was like this, that okay, if I have the, train loss, and if I have the test loss. Okay, and in case of regularization, and in case of non-regularization, if you are not having the regularization, then, I mean, if you are having the regularization, then train loss will be better. I mean, train loss will be more, not better. It will be more in case of regularization, right? So this is regularized model, because lambda is not 0. This is y is regularized model. Z is also regularized model. Okay. Z is regularized model, y is regularized model. This X is plain vanilla model. Okay, without regularization. So yes, its loss is train loss. This loss is basically the train loss. Interestingly, because this is A, right? So this loss is train loss actually. Train loss. Is this okay to everyone? Let me know. This was an interesting question, to be honest, right? This was an interesting question. Okay, so basically C is also false. So this C is false, and then what about D? In D they are saying that okay, if you are increasing the regularization parameter, and then again you are talking about the train loss, then obviously this will be again more, right? Because you are increasing the regularization parameter. So again this is true, because this is again a train loss, because A being, they're asking about A, right? So this is again about the train loss. Okay, now let me know if this is okay to everyone or not. Is this understood? So this was really a nice question. Let me know if you were able to understand that or not. Okay, so this particular question we have taken from some university. Let me just tell you the university name. Okay, this particular question we have taken from. I will just tell you the university name. I think that was Berkeley. Actually, it is not necessary, but if you want me, then I can just tell. So this was question number which one? Check 48, right? So all of the questions that we have in the AIMTs or anywhere, we directly take from universities, right? Directly take from universities. Yes, this was a Berkeley course. Okay, CS 189. CS 189 or CS 186. This was a Berkeley course, by the way, right? We have taken from Berkeley course. Okay, so I can also put the link. But yeah, I hope you understood, right? So this was from Berkeley course CS 189. Okay, so is this understood to everyone? Is this understood? So this was a nice question, right? Now let's just move to the next question. Okay, now let's just move to the next question. This question was also easy question, I would say. Okay, this question was also easy question. So in this question, what they're asking, this was a 2 mark question. In this question, they are saying that some of the examples are having y as 0, some of the examples are having y as 1. Okay, I mean y is 0 in some of the examples and y is 1 in some of the examples. Now they're asking about training error and leave one out error. Okay, leave one out cross validation error. By the way, how many of you know about leave one out cross validation error and leave one out method? Leave one out is easy method, right? How many of you have heard about it, or how many of you know about it? This was a CMU question. Okay, this question was taken from CMU. Okay, how many of you know? Most probably most of you know, right? So let's just solve this question directly. So see here, if you are having the training error, so they are saying that this is a decision tree with just 2 leaves. Okay, 2 leaf nodes. So if you, they are again telling you how to split. Okay, they are telling you that it will be splitting. It will be splitting in between, right? So 4 to 6, it will be splitting on 5. So in that case, follow the training error. See, this is a classification problem where these are zeros, these are ones, right? One example will be misclassified out of 10. So it is very easy to see that training error will be 1 by 10, right? It is very easy to see the training error will be 1 by 10, right? I mean, I could have written 0 instead of 0 by 10, but that's fine. It is very easy to see. Is this fine? Now let's just see that what is leave one out error. Leave one out error is interesting one in this case. Okay, let's just see what could be the leave one out error. Let me go to the next page and let me just tell you what does leave one out means. Leave one out means if you leave this, if you leave this, and if you tell me the error, okay, if you leave this and then if you train on this, and then you test on this, ultimately you test on this. So if you train on the whole thing, right, as they are giving the hint in the question itself, that you will be splitting on 5 only, right? You will anyway be splitting on the 5, right? So if you leave it out and then you put it back, you will be correctly classifying it, right? You will be correctly classifying it, right? You will correctly classifying it. Similarly for this, okay, for at least for this. Now what about this? Could be the interesting case. What about if you leave this? If you leave this, then it will be C. It will be 3. It will be 6. What are the midpoint of 3 and 6? What is the midpoint of 3 and 6? Because you will be basically training. I mean, your training says that okay, you will be having them on the midpoint. This is extremely important and extremely you can say interesting point. What if you leave out this? See, there will be one more question. Okay, one more question in AIMT 2. Okay, targeting the same thing. Okay, almost the same thing. I will ask you leave one out cross validation error, okay, in the almost same thing, and you might end up doing it wrong. So that is why just understand this very carefully, because I will be asking the same, okay, exact almost same, but it will be little bit different. Okay, then only you will be learning something new, right? That is actually very nice question. Okay, I've saved that question for AIMT2. I will be asking that question in AIMT2. So now let's just see what will be happening if you leave this out, right? If you leave this out, then what is the midpoint of 3 and 6? Has anybody told me? Okay, 4.5. See, if you leave one here, yeah, 4.5. Great. So Sumya is saying 4.5. This is correct, right? Okay. So yes, 4.5 is the middle point, right? Midpoint. Now if you have 4.5, interestingly, the 4.5 is not harming you. Okay, if you split on the 4.5, and then if I come back and if I just ask you that are you correctly classifying this particular point, tell me, are you correctly classifying this particular point? If you leave this out and then you put it back, is this correctly classified? The answer is yes, right? The answer is yes. So yes, this is correctly classified. So that's nice. So all of these points are not getting disturbed. All of these points are having 0 leave 1 out cross validation error, all of these points. But now let's just check on the right hand side. Probably there is a problem on the right hand side, right? So let me just copy this diagram again. Okay. See, I'm giving you the hint that okay, there will be a similar kind of question in AIMT2, so that's why just have some attention here, because I know that these kind of things will be asked in gate also. So I'm very careful while putting the questions, okay, because these kind of things could be asked in gate also. Okay, so if you leave this out, let's suppose you leave this out. Now tell me the middle point between 4 and 7. What is the middle point between 4 and 7? I think 5.5, right? 5.5. So again, interestingly, if you have 5.5, interestingly, this is also correctly classified. Okay, you don't have to be worried about it. So see, the middle point is basically 5.5. So if you are leaving this out, then you are classifying again, then it is again correctly classified. Okay, so actually the only problem could have been, I mean, see, your decision boundary can shift or change only because of how many points? Only because of either can you fill it, or can you fill this, or what are those 2 points? Because of that decision boundary can shift. What are those 2 points? Those 2 points are 4 and 6, isn't it? Because of this only. If you remove this or you remove this, then there was a chance. Okay, I mean, see, currently decision boundary is 5, but yeah, because of this the decision boundary got shifted to, I think, 4.5. Because of this the decision boundary got shifted to 5.5. So either 4 or 6, right? Other than this, it's not an issue. Okay, I mean, the decision boundary won't be shifted, so you should not be very much paying attention about these two, or about these all. Just pay attention about these two. Are these misclassified? That's my point. Are these misclassified? If you, I mean, are these having Liban out cross validation error? So these are not having Liban out cross validation error. So which means that whatever you remove, basically your decision boundary will be this only. Now this will not be having, this will not be having, this will not be having, this will be correctly classified. So only one point will be misclassified. Only one point will be misclassified. That was anyway train misclassification also. But yeah, okay. So only this point could be misclassified. Only this point, right? Because it was not possible. It is not possible to do with just one decision boundary, I mean, just 2 leaps, right? It is not possible to classify this correctly with just 2 leaps. Is this okay to everyone? Have you understood this particular question? Let me know. This was a nice question, by the way, right? So I hope you have understood, right? I hope you have understood. Now okay, should I reveal AIMT2 question? Just tell me quickly. Okay, should I reveal AIMT2 question? Okay, so from this slide there will be AIMT2 question, and I'm telling you again, the concept is on this slide, and most probably you may fall in the trick, or you actually you will appreciate that question for sure. It is easy question, but it will be very nice question. Okay, the concept is in this slide only. Actually, concept is in this line only. Okay, concept is in this line. Your decision boundary will shift just because of these 2 points. Okay, concept will be in this line. Okay, now let's just move to the next question. Yes, this question was also very nice question. This was related to data structures algorithm question. Okay, DSA question. Have you noticed that they have asked, I mean, in the last year also they have asked DFS back edge question. Okay, so they may ask these kind of questions. By the way, how many of you have seen this particular lecture of DFS? This lecture of DFS. Okay, it has got 8k views, I mean 7.9 or 8k views. Okay, and it has got many good comments. Okay, it is very good lecture. How many of you have seen this particular lecture? This lecture is very nice lecture. Okay, some of you might have seen this lecture. So this was very nice lecture. If you have not seen this lecture, then you must watch, okay, must watch this lecture, or at least you should know this DFS parenthesis theorem, right? Okay, now let's just see this question, what they're saying. In this question they are saying that you are having pre means start time, post means finish time. Okay, so some of at some of the places this particular notation is being used. Okay, so start time and finish time. I have not given this notation specifically, but yeah, okay, I've given pre is start time and post is finish time. Okay, but they might not give it. Okay, they might not even, they might skip this notation, which is fine. Okay, so they are saying that you are having this relation pre post and then pre post. Okay, so which means you're starting u and you are finishing u, and then you're starting v and then you're finishing v. So this is u, this is v. Okay, so how many of you have by the way seen this lecture, or at least know about the DFS parenthesis theorem? See, see, DFS parenthesis theorem says, okay, this theorem says that if you are having u, okay, you are starting here, you are finishing it here, and then you're starting v later on, and then you're finishing v later on, right? So basically this is the start time of u, this is finish time, this is start of v, this is finish of v, right? So if that is the case, in that case u and v will be like this. Okay, this is u, this is v, which means they will not be having any ancestor descendant relationship. Okay, there is no any ancestor. I mean, there could be on top of that, there could be some s or something. So basically I mean, you don't know whether that is there, the s is on top or not. Okay, so basically DFS parenthesis theorem says that s will be like this, and then you will be having u and v like this. Okay, I mean, I'm assuming if s is there, if s is not there, then it could be even the two different trees. Okay, two different components, which is fine. But these are not having ancestor, no ancestor descendant relationship. Okay, no ancestor descendant relationship between u and v. Now they are saying if this is undirected graph, if this is u, this is v, and now this is case one. See, first of all, there cannot be any edge either from u or from v, right? Why that is the case? Because there is no ancestor descendant relationship. Okay, so basically sorry, I mean to say that I mean edge could be there, but yeah, it will not be like this. Okay, I mean it could not be ancestor descendant, right? Okay, so case one is that if it is undirected graph. Now they're asking, is there a possibility? The question is saying two vertices satisfy this, then there is no edge that exists between u and v. Is there a possibility that you can have any edge something like this or less? See, if this is undirected graph, then what do I mean to say that if two nodes which are not having ancestor descendant relationship are having any edge? It must be the cross edge, right? It must be, by the way, cross edge, because there is no ancestor descendant relationship, so it must be cross edge. Do you agree with me? It must be cross edge, right? Now can undirected graph has cross edge? Undirected graph in DFS cannot have, right? Cannot have cross edge. See, all of these concepts about the DFS are extremely clear in this particular video. This particular video has got many comments. Okay, and this particular video has got many nice comments and many I mean, it is not about the comments. Actually, I have covered, this is a 4-hour long video. I've covered everything about DFS in this particular video. This is my favorite video about the DFS, and I'm 101% sure that if you watch this video, you will not forget DFS at least okay, at least for 2-3 months. Okay, I can say at least for 2-3 months you will not forget. There are many questions we have solved here. Okay, so in DFS, cross edge cannot exist. It must be the cross edge, but cross edge cannot exist in case of undirected. So that is why it is false. Okay, the first statement is false because of the cross edge cannot exist. The second statement is true because the cross edge can exist in case of directed. If it is directed, let me write here. So if it is directed, UV, if it is directed, the cross edge can exist. Now, can anyone tell me if this is the relationship? This is going to be a nice question. The cross edge can exist, but the cross edge will be like this or this. Can anyone tell me? The possibility is like possibility number 1 is possible or possibility number 2 is possible. This is going to be again a next interesting question. ओके सो फैजन खान इज सेइंग सर गो क्लासेस से नहीं पढ़ पाया बट अब कोशिश कर रहा हूँ कि टेस्ट से ही कुछ समझ सकूँ. सी फैजन खान, यू कैन जस्ट सी सत्यम इंटरव्यू. ओके, सत्यम हैज गॉट AIR 4 in gate 23. Not just Satyam, I will tell you many other names, but I am just telling you for now Satyam, gate CACIR 4. Okay, you can see his interview on our channel. In 2023 he has got this rank. He was also in the exactly same situation. Okay, he was also in the exactly same situation. He also said in the interview that okay, he has not understood, or he has not actually watched go classes videos other than the free videos. Obviously you might have watched free videos, but doesn't matter, right? So he has also learned many new concepts. Okay, he was crazy, he was actually crazy about the AIMTs and all the full length test. Okay, so you just watch his interview. He was saying that he was actually crazy about the AIMTs and other full length test, and eventually he was scoring AIR 4, as you know, right? And rest is history. So just watch his interview, and not just him, there are many other toppers. Okay, there are many other toppers like him. Okay, so don't worry, all right? I mean, there are many other toppers who have not seen our lectures before, because our coaching is not very popular like other coachings. Okay, so that might be the reason, right? We are having very less reach, but don't worry about it. There are many other toppers who score very well just using our full length test. Okay, so just take this opportunity, okay, and keep on learning. Okay. तो यस, तो मी टू के सिंह मैं भी नहीं पढ़ पाया. डोंट वरी, बस अभी आप ये वाली अपॉर्चुनिटी लो एंड जस्ट कीप ऑन लर्निंग. तो जस्ट टेल मी, इज पॉसिबिलिटी 1 इज पॉसिबल, पॉसिबिलिटी 2 इज पॉसिबल. So see here that 1 is not possible, right? I mean, if 1 is possible, then obviously if you're starting you, there is no way you can finish you before finishing. I see you started you, okay, you are doing something, and then if you have this as you want to be finishing you, right, you will be basically going to the depth, right? And then once you finish all of its answers, so basically if 1 is the case, in that case you, once you start you, in between somewhere here you will be starting V and you will be finishing V also. Okay, it will be under you, right? So basically 1 is not possible. On top of this, 2 is possible, because you can start U and you don't know about V, because this size is like this, right? You don't know about V. Later on you start V, but obviously since U is already explored, so you want to be going to the U. So this is possible only when you have this kind of scenario, which means U and then V. So basically V to U is possible. Okay, V to U is possible, U to V edge is not possible. And if you are not understood this, again this lecture will make everything extremely clear. All of these things, everything about the DFS I have discussed in this lecture. Okay, now let's just move to the next question. So basically here, this is false, this is true. So you can say S2 is true. This was a nice question. Easy. Okay, it was, to be honest, easy question. Only way you could have found it hard because you have not studied DFS. Okay, if you watch this lecture, this question, this particular 2-mark question will be very easy for you. Okay, this particular 2-mark question will be very easy for you. And this is a potential gate question. Definitely these kind of questions will maybe asked in gate also, right? Okay, now let's just move to the next question. Okay, by the way, this question was interesting question with respect to, what they have asked already in gate. Okay, so do you know that they have asked similar kind of questions in gate also? I mean, last year in gate D itself. How many of you were able to solve this question? This was little different question, by the way. Okay, so last year in gate D, they have asked a similar kind of question. Let me just tell you that question also. Okay, this is last year Gate DA question, Gate 2024, Gate DA, okay, question. So they are saying that consider full binary tree, okay, full binary tree. Now in this question I am saying consider a complete binary tree. That's the only difference. How many of you were able to solve this question? Do you know that after this gate question, I put we have already solved these kind of questions in the class. So I put the class recording over the YouTube. Okay. And the heading was most experienced made this question wrong about full binary tree. That was the heading. Asked first time in gate history. Okay. Actually, that kind of question asked first time in gate history, but we have already solved that question in the class. Okay. And I immediately put that particular link or particular video on the YouTube. Okay, after the examination hall. Right. So let's just see this question. Okay, great. So, okay, I'm really very happy to see that many of you have done this correct, right? So you are saying ABC is the correct answer. That's really great. So in this question, many of you are saying that ABC is the correct answer. That's really good to see. So in this question, what they are saying, let's just see. They are saying that you are given a complete binary tree, right? And then for a complete binary tree, you want to uniquely reconstruct this tree. Which of the following is sufficient to uniquely reconstruct this tree? So basically, if it is complete binary tree, then just any of this is fine. Any of this is fine. If this is complete binary tree, how that is possible? Just see this video. Okay, see this video. Okay, see this video for the concept. Even basically on the gate or flow, I just answered this question. Okay, and the answer of this question is something like this. Let me just paste the answer in the answer. I'm just recommending to see this video. Okay, this is the answer that I have just put. Okay, maybe I think 1 hour ago. So I'm just saying that watch this video to understand this concept clearly. Okay. So you can watch this video and then you will get to know in case of complete binary tree. In case of complete binary tree, only one of them is enough. Okay. In case of full binary tree, along with the in order, either pre-order, sorry, in case of full binary tree, yeah, you tell me what is the answer? In case of full binary tree. So what is the answer for this? Any two is fine, right? Any two is fine. So either these two, or these two. This is very interesting concept. Okay. In case of full binary tree, any two is fine. So that's why these three are answers. Okay. I mean, in gate also ABC was the answer. Here also ABC is the answer. Okay. Now let's just move to the next question. Okay, let's just quickly move to the next question. Yes, this is actually very interesting question, and the similar question has been asked in GATE 2024. फैजन खान is saying, सर मैंने डी लगा दिया था, मुझे लगा कॉम्बिनेशन से बनेगा, राइट? हाँ, दिस इज एक्चुअली लेस पॉपुलर फैक्ट, सो दैट इज फाइन. मतलब इट इज ओके, यू कैन वॉच दिस लेक्चर, राइट? So you can watch this lecture. That is actually less popular fact. So that is the reason I'm putting these kind of questions selectively in AIMTs, so that your concepts will be more stronger, right? Now let's just see this particular question. What this question is saying: consider a rooted binary tree with a distinct node values where the tree has height 10. Note a tree with okay. So they are saying if this is only root, then height is 0. Okay. The tree has a property that in-order and post-order traversals are same, right? So what is in-order traversal and what is post-order traversal? In-order says you have left, root, right. What is post-order says? What does post-order says? Post-order says that you have root, left, right. Okay, so they are saying that these two are same. Okay, so in order and post order both are same. How it is possible? See, for any tree, is this, are these, can you find out the in order and post order for this? In order is basically you can directly take the projection. BAC is in order. Okay, what is a post order? Post order is basically you can say post order is left, right, root, right? Oh, sorry, I think sorry, I mis typed it. So it is left right root. Right? So left first, then right first, then right, and then root. So BCA is post order. This is post order. Even for a small tree, something like this, the in order and post order are not same, right? But what if you don't have right even, right? What if you don't have right? See here that if you want both of them to be same, right? Uh, see, left and root are in the same order, by the way, but the right is coming in between. What if you don't even have the right, right? I mean, you never have the right. Right is null. Okay, if right is null, then in order and post order will be same, right? So basically, if the tree is something like this, now you find out the in order and post order. In order is basically CBA. Post order will be uh, post order is basically left right root, right? So left, so you will say C, and then there is no right, okay, and then root CB, and then left is completed, there is no right, so CBA, right? So CBA, this is post order, this is in order. So basically the tree is left skewed, okay, tree is left skewed, then it is possible. I mean, if you eliminate this right, if let's suppose tree is right skewed, then in that case, in order is ABC. What is post order? Post order is left, right, and root. Okay, so left is nothing, right means this whole thing, but root actually, I mean, whatever you do, but root will be A, right? So root will be at the end. So it is not. I mean, these two will not be same, right? So if you eliminate, what I'm saying, if you eliminate, let's suppose left, if you eliminate left from both, then root right, this is right root, so it will not be same. You have to eliminate right from both. Okay, if right is null, then it will be left root, this is also left root. So if right is null, then it is possible. Then what is the answer here? So it will be left skewed. So if you make the left skewed tree, then with the height 10, right? If the height 0 is root, so height 10 will be basically 11 nodes. Height 10 will be 11 nodes. Yes, it was actually good question. Okay, so this question again, see, all of the question, you can actually tell me any question, I will tell you the link of that question, because all of the questions are from standard universities only. So yes, this question was from Berkeley University, I think. Yes, it was from Berkeley University. Okay, so is this understood to you guys? Let me know. Okay, okay, so now I think it is well understood, right? Okay, now let's just move to the next question. Let's see this question. This question was related to Python. I mean, Python and recursion. So you can say it is algorithmic question. Okay. Okay. So in this question, what they are saying, you are having some functions separate. Okay, and then it is doing the recursive calls. Okay, it is doing the recursive calls. So what the separate is doing? Let me write SP. So you are calling on the data 1 2 3 7 2 4, right? And then if the data length is 0, okay, so currently it is not 0, so you will basically proceed further. If this is odd number or this is even number, based on that you will take a call. Okay, so if this is odd number, okay, so currently it is odd number, the first number is odd number, you will say that return data 0 1. So which means, I mean, what does this 0 1 means? Can anyone tell me? Is this 1 2 or is this only 1? Is this 1 2 or is this only 1? Just tell me quickly. This will be only 1, right? So they are saying basically it will be a list which will be containing 1 plus separate 1, okay, afterwards. So basically 1 plus 2 3 7. So what was the answer for this question? Okay, so was this question tough for you guys? So I think answer was B, right? Okay, some people are saying D, but answer was actually B. Now basically you are having the recursive call on this. Okay, so you are basically saying that if this is odd, then just leave it as it is, basically this one, and then you are having the recursive call on the next thing. If it is even, then you are doing something. If it is even, then you are doing what? You are taking this, okay, and then you are saying that okay, then basically it is returning one, basically one from one onwards, right? So basically this is 0. Now this is for this particular call, this is 0, this is 1. From 1 onwards you will be returning, so it will be already 1, plus from 1 onwards you will be returning, right? So 3724, I mean this you will be calling recursive call on this, and then plus 0 1, which is 2. So basically 2 will be at the end. If it is even, then 2 will be, or if it is, basically you can say, if it is even, then you will put that even at the end, right? So maybe you can now understand. Okay, this is interesting question, by the way. 3724, right? Now for this, what will the answer? So if it is odd, you won't do anything. 1 3 and then 724, and then basically 2 will be at the end, right? Now recursive call is on this, so 724, right? So 724, what you will do? If it is odd, then what you will do? If it is odd, then you are not doing anything, right? So 137, and then on 24 you will be calling, and then 2 is at the end. If it is even, now it is even, then what you will do? You will put this even at the end, right? So it is 137, and this is 4. You will put even at the even end, which is 2 2, right? And then if it is even again, now it is basically just one element, so it will return directly, right? So basically 137 422. Okay, this is interesting question. This was a nice question, right? Wow, nice. Okay, so it was a nice question. Now let's just move to the next question. But if there is any doubt in this question, I will just clarify. Okay, so basically maybe I can just go over the explanation again. If there is any doubt, you can just let me know. Okay, let's just paste this question, screenshot again. See what they are doing in this question, something like this. They are saying you are calling with 1 2 3 7 2 4, right? Okay, you are calling with this, right? This is separate. Now if it is odd, then you are not doing anything. One, I mean this will list plus some function call on this, okay, which is whatever the separate is returning, 2 3 7 2 4. Now if it is even, then it is interesting. Then you will do what? You will say that okay, if it is even, then you will call the function call on 3 7 2 4, right? And then this is anyway 1 plus whatever this returns, and then whatever this returns plus at the end 2. Okay, I mean later on it will be plus 2. Okay, so now we have to check that what it is doing, but till now it is fine to everyone. Okay, so basically it is doing something like this, right? Now you can again check that what this is doing. So now you will say that okay, if it is odd, it won't do anything, so it is 1 plus is anyway, so I'm actually here stuck, right? So I will be having 3, then plus again 7. I mean I'm doing 2 recursive calls. That's fine, because or it is like this. If it is even, it will put it at the end. Okay, at the end. So 1 plus 3 plus 7 plus, by the way, at the end doesn't mean this, because at the end anyway this is plus 2. So at the end it will be this, so it means 2 plus 2. So what do I mean by that? That this 2 is this one. Okay, this 2 is anywhere at the last. Okay, this 2 is anywhere at the last, so this 2 is this one only. So yes, that's interesting question. Okay, very nice. So how many of you were able to solve this question? Let's see this question. This is, I will say, if you know the definition of diagonalization, okay, just the definition is fine. I'm not asking you to know all of these things, just the definition is fine. If you just know the definition of diagonalization, then you could have solved this question. Okay, basically it means that eigenvectors are linearly independent. eigenvectors. Okay, not diagonalizable. So it means eigenvectors are not linearly independent. Okay? Eigenvectors are not linearly independent because of not diagonalizable. That's all. Okay. Now they are saying if this is the characteristics matrix, then what could be the rank? So maybe I can just simplify this. So you will say that lambda equal to 0 is having multiplicity 2, right? By the way, what does this mean? It means that, see, there will be linearly independent vector for this. I mean, because this is just single, but if lambda equal to 0 is repeating 2 times, so just one linearly independent or just one vector you will be getting. Okay, you will not be getting two vectors here. Okay, so basically you will say that corresponding to lambda equal to 0, this is important, corresponding to lambda equal to 0, just one vector we will be getting, just one eigenvector, unique eigenvector, right? And once this information is basically processed, okay, once you get to know this information, right? Because how we got to know this information? Because this is not diagonalizable. It means, see, for this, obviously, since this is just having one multiplicity, so one linearly dependent, one linearly, no one can stop it, right? One separate. But for this, for lambda equal to 0, since it is repeating 2 times, now I can have either 1 or 2. If I have 2, it will be diagonalizable, so I must be having one, just one linearly dependent vector. So once you know this, it means it is nullity. Okay, it is nullity. Now you can say that, okay, nullity is basically 1, so rank is since this is 4, so 4 minus 1 is 3. Okay, that's very nice question, to be honest. Nice and easy question. It is not at max, it is exactly equal to 3. It is not max. Okay, rank is exactly equal to 3. Exact, not max. Okay, let me know if you have understood this question, because this question was actually very nice question. Was this question clear to everyone? Okay, great. No, at max it cannot be 4. I mean, since lambda equal to 0 is at least will be there. I mean, it will be basically the part of the eigenvalue, so it cannot be 4 also. But yes, it can be 2. I mean, if it is diagonalizable, okay. If not, what is not there, then what is the rank? Okay, it might be the potential AIMT 2 question. If not, what is not there, then all the all the eigenvectors are linearly independent. It means according to lambda equal to 0, there are two linearly independent vectors. It means nullity is 2, then rank is 2. Okay, then rank is 2. Okay, if all linearly independent eigenvectors. Understood? So if not word is not there, then the rank will be 2. If not word is there, then rank is 3. Okay, because you can find out the nullity and then you can find out the rank. Yeah, this question was related to quadratic forms. By the way, quadratic forms is a part of official syllabus. Let me just tell you. Okay, let me tell you GATE syllabus. So you might have seen this, but I can also tell you. Like, for example, rank nullity. Is this mentioned? Yeah, right. Quadratic forms. So this is mentioned here in the GATE official syllabus also. So these kind of questions could be asked, right? So they are saying, given this quadratic form, whether this is PD, I mean positive definite, PSD, positive semi-definite, and so on, right? So maybe you can see this particular lecture regarding the quadratic forms and the positive definite. This is available on the YouTube. It has got 2K views, so you can just see this lecture, okay? To see this particular topic, don't, and then you will be able to solve these kind of questions very easily. Okay, so just see this particular lecture, right? So here what you need to do, you just need to form a matrix. Okay, and then these are the conditions to check quadratic I mean any matrix is positive definite or not. So basically you can check the principal upper left determinants only. So if you make the matrix, okay, if you make the how to make the matrix, you see this is the coefficient of x square, I mean xx. Okay, so maybe I can just, all of this is actually given in the lecture, so I cannot actually repeat the concepts because this is a question solving session. So I can just point you out that okay, how to understand this concept if you already don't know. Okay, I can just point you out. So by the way, the matrix will be something like this. This is the xyz, this is xyz, right? This is the coefficient of x square, this is the coefficient of xy, this is the coefficient of xz, this and so on, right? Like that is how you can basically make this matrix. Okay, and obviously it will be symmetric matrix, right? It will be symmetric matrix because coefficient of xy and coefficient of xy, this is the coefficient of xy, and coefficient of x, obviously it will be same, so it will be symmetric matrix. So you can you can check that lecture, and then what you can do, you can find out the determinant. So determinant of 3 is 3, determinant of this is basically 2, and determinant of this whole thing is basically minus 2. Since one of them is minus, that is why it is neither PD, I mean one of them is plus, one of them is minus, that's why it is indefinite. Okay, neither PD nor PhD, then it is indefinite. Understood? And for this you can watch this lecture, right? See, we will be finding so you can do all of any of this. Okay, either you can find all the eigenvalues, or you can find all the pivots, or you can find the upper left determinants and all. Okay, so any of this is okay. Okay, all of this is given in this particular lecture number 24. By the way, this is a part of official syllabus, this quadratic forms. Now let's see this question. Let's see that how to solve this question. So in this question they are saying that 1 2 is represented in basis B as 3 4. So basically what does this mean? Can you tell me? It means that 1 2 will be, I mean in basis B, if you represent this 1 2, it will be 3 4. So 3 4 is in the basis B. Okay, this is in the basis B. So you just multiply with the basis to convert in the standard basis. Okay, so it will be like this. So you can say maybe you can say 1 equal to, this is 3v1 1 2, right? 1 2 equal to 3v1 plus 4v2. This is one equation. Okay, another one you can make like this, right? So again you can say that 3 5 is equal to 2 3 v1 v2. Now they're asking about the v1 v2, that which of the following is this v1 v2. So basically you need to solve for v1 v2 only. Now what you can do, there will be another equation 3 5, which will be 2v1 plus 3v2. Now what you can do, you can just multiply by 2 and 3, and you can eliminate one of the vector from here, and then you can try solving this question, right? This is just two equations, two unknown. Okay, and just in the vector form, which I completely agree, but you can solve it. Okay, even though this is in the vector form, still you can solve it, right? Two equations, two unknown. Understood? Okay. Now let's just move to the next question. So this question was again related to the block matrix, and again I would like to specify just a second, that block matrix is basically part of the official syllabus only. Okay, why I'm telling you these things again and again, because some people think that we are putting out of syllabus things and these things. Okay, might think something like this, but it is never our aim. Why would we be doing this, right? I mean, what is the purpose of doing this? So partition matrix and block matrix are same. Okay, this is a block matrix only. Partition matrix or block matrix is part of official syllabus only. So block, you call it block matrix or you call it partition matrix, both are same. So what they're saying, this matrix is given. Okay, for this matrix to be singular, what should be the value of alpha? Okay, find the values of alpha. Okay, for which of the following values of alpha it should be singular. So if you're dividing in the block, see, again I'm suggesting you, what you can do, you can watch this partition matrix or the block matrix lecture on the YouTube. Okay, this is lecture number 23. Okay, so in this particular series you can watch this lecture, and then you can get to understand this concept even more. Okay, but for now let's just solve this question. So see, if you just partition it, so you can do you can find out the determinant of A using the blocks. Okay, this is the determinant of this into determinant of this. Okay, minus determinant of this into determinant of this is 0. That is the key point here, right? That is the key point here. So determinant of a is basically determinant of this into determinant of this. Determinant of this is this, the determinant of this is 8. So if you want it to be singular, then you will be putting it as 0. So for alpha equal to 1 it is singular, and or you can say or for alpha equal to 8 it is singular, right? So either alpha is 1 or alpha is 8. For both of these values this is singular. Okay, so you can apply the block matrix concept, which is basically like this, that you can take that this determinant, this determinant, you can apply the block matrix or the partition matrix concept, or you can alternatively what you can do, you can basically have this matrix A and don't worry about these blocks, right? You have this as it is, then you just convert into the Gauss, I mean you have the Gauss elimination, and I think almost all the pivots are done. Only you need to make it 0, right? If you do this, then you will be getting these as pivots, right? These as pivots. So now you can find out the determinant of this. Okay, now you can multiply all of this, and then you can find out the determinant, and then you can say the determinant of A is 2 into alpha minus 1 into 2 into 4 minus alpha by 2. So either this is 0, which means alpha is 1, or this is 0, which means alpha by 2 is 4, which means alpha is 8, right? So you can do in any of this way. Okay, so yes, this question was also, I think, doable question. Okay, so have you understood this question? Let me know. Right. Okay, now let's just move to the next question. This is question number 60. Okay, in this question they are saying consider the following directed weighted graph. Even though the graph has negative weight edges, digest algorithm to calculate supposedly okay, which of the following is or are correct? Okay, now let's just check this. So they are saying the order in which the vertices are ordered in the sorted sparse tree. Digesta is this the order. Okay, they are asking about the order, right? And they are also asking about the digester algorithm find the wrong path to some of the vertices. Okay, so basically we need to run the digester algorithm here, right? We need to run digester algorithm here. So let's just run this quickly and let's just solve this question. Okay, so this is question number 60. Let's just run digester algorithm to solve this particular question. So do you remember how to run digester algorithm? By the way, again, digester algorithm is in the syllabus, right? Let me just copy only the image. Okay, so shortest path algorithms is in the syllabus. Okay, that's why we are giving these things, right? Now let's just see this question. So they are starting at A, right? Okay, from A. Okay, they are starting at A. Now initially this is 0. Everything else is infinity. Do you remember this? Everything else is infinity, right? I mean these are the priorities. Now if you run this, this will be 2. This will be 7. Okay, this is 12. I think these are the 3 edges, and then if you run this again based on this 2, so first A will be in the picture. I mean A obviously the source, and then minimum out of 2, 7, 12, infinity, 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 out of all 2 is minimum. So you will say okay, B is final, A is already final, so B is the next final. And then if you run this again, it will be 2. So it is 2. I think only one outgoing edge is there, so only 2. Now if you check the minimum among all of this, so maybe 2, 7, 12, infinity, infinity, minimum is 2. So basically you will again pick this, right? And then you will say that okay, D is the next one which is picked, and the answer is 2 here. Then this is 2, so that is why you will say this is now, sorry about it. So it is actually 4, not 2. It is 4, right? So anyway, the answer won't change, but yeah, it is 4. Okay, because 2 plus 2 is 4. Now 4 will be picked, and then this will be 6, right? This is 6. Then I think there is only one outgoing edge, so that is final. So now out of 7, 12, and 6, I think 6 is minimum. So this is 8. Out of 8, 12, and 7, I think 7 is minimum. So after G, and then C will be picked, right? And then 7 and plus 2 is 9. So this is 9, and then E will be picked. So A, B, C, D, E. Okay, I think I forgot F. F was picked before G, right? After D, F was picked. So F was picked here. So A, B, D, F, G, C, E. ABDF I think A is the correct answer here. I mean, this is MSQ. We will check other answers also, but is the A correct answer? ABDFGCE. ABDFGCE. Or CGE is the answer. Okay, I think C will be here because this is 7 only. CGE. Okay, it was CGE. Sorry, I just messed it up a little bit, but I hope you understood. It is CGE. Okay. It was CGE because C will be first because C is basically having 7. Okay. What was 8? Like, should I rerun this? What is the answer for this question? By the way, just to verify. Okay, B is the answer, right? CG. Let's just quickly rerun this and let's just see where was the mistake. This time I will be careful. See, this is infinity. I mean, initially this is 0. Everything else is infinity. And then this is basically final. So A will be first. And then this is 2. This is 7. This is 12, right? Then B will be the next. Is this okay to everyone? Then you will relax this. Okay, you will say it is final. You will relax this. This will be 4. And then you will say next is D, right? I hope that is fine, right? Now you will relax this. And since initially it was infinity, it will be 6, right? It will be 6. And that's all. So you will pick this. So among the 6, 7, 12 and infinity, right? Among all of this, I think 6 is minimum, right? So you will pick this F. You will pick this F. And then you will say that, okay, this will be 8, right? And yeah, there is only one outgoing edge from this F. Now among the 7, 12 and 8, which one is minimum? Now C is minimum. You will pick C, right? Now you will say 7 plus 2 is 9. Okay. And that's all. So among this 8 and 9, which one is minimum? G is minimum and then E is minimum, right? G is minimum and there is no outgoing edge from this. So E is minimum. So these are the final numbers. A, B, D, F, C, G, E. So A, B, D, F, C, G, E, right? So B is the correct answer. Now they are saying this algorithm find the correct answer to all of these, or maybe wrong answer to some of this. So what is the answer of this? So let's just check, right? Let's just check. See, is this finding any wrong answer to anyone? See, we are never relaxing this negative edge, right? This is the hint. This is a big negative edge and we are never relaxing it. Okay, we never got chance to relax it, and this is a good hint, right? So from E maybe -7, and then we never got chance to relax it. So basically -7, and then you will say that, okay, I mean, relax in the sense that you I think you have first picked G, right? Since you have first picked G, so you have not used this -7. Since you have not used this -7, so 9 -7 should be 2. I mean, you can easily reach using 2. So basically you are finding wrong path to some of the vertices, right? So B and C are the correct answer. Okay, is this understood? Let me know. It was a good question. Let me know if that is understood. Okay, now let's just see the next question. Okay, this was easy question. So here they are saying, but interesting one, right? Here they are saying you have partial label order, right? So which means you have 80, and then I mean label order means level by level, right? Now in the next level you will be having some elements. Okay, some of this, I mean 2 elements basically, particularly. Now 40 will definitely on the left and 110 is on the right? Now on the next level you will be having more elements, right? Four elements could be, these 4 elements could be all of this, I mean something like this, right? See, but on the next level, if you are having 100, then 100 should be on the right hand side of 80 and 100 must be here only. It cannot be in any of this, right? So basically if 100 is here, then only one element is there, right? I mean, this question mark is either left child or right child, right? I mean, question mark and 100 is not basically having the same parent, right? Because 100 must be here only, and question mark, right? This question mark might be the left or right. See, here also you are having two elements. I mean, at least one, see, at this particular level, at least one node will be there, right? At least one node will be there. Now you will be saying that, okay, if 100 is here, then 100 must be on the right of this and on the left of this, right? So 100 must be here. So only one element is remaining, and which is question mark. So question mark is either here, either left or right. You don't know basically, right? And then 120 will be on right of this, and then 60 is remaining. So 60 will be, you can say, left of this, and then right of, if the right of 40, then it must be like this. Then question mark must be the right child. Okay, question mark must be holding this particular position. Once you identify this, then you can solve this question. So what does this mean? Then it must be lesser than 80, greater than 40. Okay, and then if you're putting something on right hand side, this lesser than 60 also. Okay, so lesser than 60 and greater than 40, it will be between 40 and 60. So you can say question mark is any number between 40 and 60. Okay, any number between 40 and 60. Actually you can have the in order, or always you can have the in order. Okay, 40 will be here, question mark will be here, 60 here. Question mark is basically in between 40 and 60. So any number between, which is between 40 and 60, or can be 70 also. Just a second. So basically 80 is there. Sorry, 60 could be left side also. Okay, this is interesting here. 60 could be left side also, right? So till now it is okay. I mean, till now that is fine. Now if you are inserting 60, so 60 could be here or could be here. It doesn't matter, right? So question mark position is by the way fixed, right? Question mark position is by the way fixed. So basically, say 60 could be here or here. 60 position is not fixed. So you can say at least, okay, it is need not to be greater than 40 and less than 60 need not to be, but yeah, it is basically between 80 and 40. Okay, question mark is any number between 80 and 40 basically, because 60 position is not fixed. Okay, so any number between 40 and 80, any number between 40 and 80. So that is the reason I think A and B are the correct answer. So can you tell me the answer? Okay, is there any doubt with this question? This was question number 63. I think this is clear. I can again explain this if there is any doubt. Okay, so yes, A and B are the answers. So let me again explain this if there is any doubt. See, just try to understand again. See, this is the label order is given, right? So you start with 80. You start with 80. Then obviously 40 will be here and 110 will be here. Okay, which means that, I mean, there is no possibility that you can have any other thing. Okay, I mean, there is no possibility that you can say, okay, there is basically only the trees left is skewed or something like this. I mean, there is no right child at all, because 110 is there, right? So 110 must be here. Now at the next level, okay, there are like four possible nodes at the next level. Now let's just see what are the, see this, if 100 is here, 100 must be here only, right? 100, and then if 120 is here, 120 must be here. I mean, these are the fixed positions. Now where this question mark? So question mark basically will be either left child or right child, because you don't know, because it was a label order traversal, right? And based by whatever this question mark, right, and then the 60 will be, it can be left child, right, doesn't matter, right? Then 60 will be something like this. See, then 60 will, see, 60 has to be inserted, right? So 60 will be basically, if it is left child, see here, the interestingly here there will be only one child, either left or right, but it has to be actually right child only, because again if you are having 60, then 60 will not be possible to insert if it is left child. So it has to be right child only. Okay, So 60 is either here, doesn't matter. But yeah, it has to be right child only, because if it is left child, then 60 you can't insert anywhere. So question mark position is now fixed. Okay, maybe it is greater than 60, 60 less than 60, we don't know. Okay, but question mark position is not fixed. So it must be less than 80. Okay, it cannot be 90, it must be less than 80 and greater than 40, because it is fixed onto the right. So greater than 40 and less than 80, any number. Okay, any number which is greater than 40, less than 80 can take this position. थर्ड लेवल पे क्यों नहीं आ रहा? दिस इज ओके, थर्ड लेवल राइट. No, 60 is you are doing level by traversal, right? 60 is after 120. After 120, it means it must be after 120. Okay, it must be here. Okay, if you are labeling maybe 0, 1, 2, 3, or I don't know. Okay, you are labeling 1, 2, 3, right? So you are saying 60. Why 60 is not here? Because it is after 120, right? It is after 120 means that it must be first 120 and then 60. 120 and then 60. Okay, any other doubt here? Okay, I hope that is understood. So 50 and 70 is answer. Any number which is greater than 40 and lesser than 80, right? Something like this. Anyway, so 50 and 70 is the answer, because this number are greater than 80. These all numbers are greater than 80. It was a nice question. It was also a nice question. So do you think overall paper was tough? I think it was little more conceptual than I was expecting. Okay. Do you think overall paper was tough? What do you think? So this question, question number 64, it was easy question only. So they are saying that you have this starting arrangement. The same question, I mean the similar question was there in AIM. Okay, no, not in AIMT. Sorry, this is just AIMT 1. So I thought it is okay. I just missed it. So in one of the mock. Okay, if you have seen that mock 3 or mock 4, I don't remember. But in one of the mock, okay, in mock 3 or 4, one of the question was there. Okay, we were asking about the merge sort. Has anyone solved that question? We were asking about the merge sort. I mean the configuration given was same as merge sort. Okay, so here this is insertion sort. Why? Because this is initial stick positions. Now insertion sort does what? It is keep on sorting from left. Okay, keep on inserting. So if you notice that, see this stick position. Okay, so maybe I can use a different color. So if you notice, after the stick position, including the stick, right, nothing has changed. After the stick position, including the stick, nothing has changed. So basically you can say that it has keep on sorting from the left. It means it must be the insertion sort from all of given choice, right? So it is this part is sorted. So who does these kind of things? That nothing is changed from this part. Who is not changing anything from this part? Insertion sort, right? Insertion sort is not changing anything on this part, and minimum is like this. Right? This way, B is the correct answer. Okay. Why bubble sort? Bubble sort will be keep on shuffling, right? It will not be making sure that okay, this part is 100% sorted. I mean, by the way, bubble sort. I mean, even if it makes sure, bubble sort will change something here, right? Bubble sort will change something here. It is not changing anything on this segment. Not changing anything from this segment. Right? Bubble sort will be bubbling on that segment also. Okay. Okay. Now let's just move to the next question. I hope that is understood. Yeah, that was a good question. So here they are saying you are having comparison based sorting algorithm. In comparison based sorting algorithm, we we have at least, this is least, okay, at least n log n. I mean, actually in all sorting algorithm there are few which are like radix sort and all, which are very special cases and which only runs on very special numbers, right? So anyway, like you can say in almost all the algorithms we have n log n at least time complexity. Now they are saying which of the following options are enough evidence to prove or disprove if a given comparison based on the sorting algorithm works correctly. Okay, this is the question that they are saying. Right now, let's just see this. Okay, so someone is saying, sir, can you try the other options also? See, the merge sort, for the merge sort you will be dividing in the half and then you will be sorting this half like this, right? So we are see, first of all, this is not half, by the way, right? This is not half. The half could have been something like this, right? Half could have been something like this. So this is not half, so that's why merge sort is not the answer. What does the selection sort does? It basically find the minimum or maximum, whatever you like to do, and then it will keep on putting on the left and right? So basically the minimum is this element, right? So minimum is somewhere here. So selection sort will pick this and will put on the left hand or right hand. So selection sort is not there because this element is not disturbed, right? Or maybe selection sort can pick the maximum also. So maximum is this, or maybe this. So I mean, basically it is very clear that the selection sort basically picks something like this and then will keep on, you know, putting on the left hand or right hand. So I think there was one question, yes, in gate CSE AIMT2. In gate CSE AIMT2 there was one nice question related to selection sort. Okay, selection, you just try that question. Okay, you can try that question, gate CSE AIMT2 selection sort question. That was a nice question. Now what they are saying, Professor A gives comparison based sorting algorithm such that runs in this particular time complexity. Okay, this is sufficient information to conclude the correctness or incorrectness. So see, they are saying this is running in this particular time complexity, and if you just solve it, it is coming out to be 2 power n. Okay, someone is saying I have a sorting algorithm which is basically giving the which is sorting in 2 power n time complexity. Is this sufficient information? That is the question. The question is about the sufficient information. See, it is not, see, we cannot prove it. Just using the time complexity, we cannot prove it. We can only disprove. Okay, we can only disprove. Right? So we cannot prove it. So basically we cannot prove. We can only check if someone is giving lesser than n log n, then we can say okay, he is wrong. That's the only point. Okay, so it is greater than n log n, we don't know. Okay, we don't know whether it is correct or not. We cannot prove or disprove if it is greater than n log n. What about option B? If you solve option B, maybe I have the next page, I can go to the next. If you solve option B, it is n log n. Is this lesser than n log n? Okay, what about option C? Is this lesser than n log n? You just tell me. Okay, and is this so basically in option D I am getting n. Is this lesser than n log n? So whichever is lesser than n log n, I can only disprove. Okay, so tell me which is lesser than n log n. So yes, option B is lesser than n log n, because this is anyway lesser than, yes, this is lesser than. Is this lesser than n log n? N power 1 into n power 0.8. I mean, I'm just writing like this. So n will get cancelled out. This number, so you might know this. Okay, if you don't know this, I will tell you the link of the video where you can watch. N power any small positive is actually far greater than, asymptotically I'm telling you, log power, okay, log n power any big positive. Okay, so n power 0.8 is basically far greater than log n. Okay, even if I write log power 100, and it doesn't matter. Okay, what number I write here, it is actually it is still greater. Okay, so you can check one video, maybe if you are a little bit confused about the asymptotic complexity. Let me just tell you. Okay, there was a marathon that I have taken. You just watch this video and I think you will never be, disappointed, or you will never be confused with these notations and these questions. So maybe tell you that. So you can watch this video. This video has got 14k views. Okay, 14,000 views. This video has got 14,000, right? And there's a reason behind it. If you just check comments on this video, right? You just check comments on this video, you will be realizing that how much good this video is. So just comments. Okay, so this is very nice video. You will in this video I have actually talked about all of this concept. This concept was discussed in that video only. So you can check these comments, right, of that video. Back section is a very nice lecture. Okay, studied this topic many times, but no one told why takes logs or not, and best coaching institute so far, and so on. Okay, so these are many good comments that we have on this video. So just check this video, right, if you have not already gone through this video. Okay, so anyway, this is lesser, right? This is not lesser, this is actually greater, and n is definitely lesser. So yes, whatever is lesser I can disprove. I can say it is not correct, I can disprove. But just by having, if something is greater, I cannot tell anything. Okay, it doesn't tell anything. Okay, if something is lesser, I can disprove. Okay, so I can only disprove here, I cannot prove just using the time complexity. Okay, so that is why I can say about B that it is this algorithm, this professor algorithm is wrong, this professor algorithm is wrong. What about professor C algorithm? What about professor A algorithm? I don't know. Okay, so they are saying which is enough evidence to prove or disprove. So who is having enough evidence? For B I am having enough evidence, for D I am having enough evidence. Understood? Let me know if there is any doubt. It was actually a nice question. Let me know. So this is the end of question, all the questions that we had in AIMT. Now if we have still any doubt, you can just leave a comment and I will be just answering. Okay, we have seen the detailed video solution for all the questions. If you still have any doubt, just leave a comment. Okay, I will appreciate if you can just write something good in the comments, so that future aspirants will just see it and will just get to know the quality of the video. Okay, I mean, I'm not asking you to do it forcefully. If you genuinely feel that okay, we had very good AIMT and we had basically very good discussion, then I will just request you to put a comment, right? So that whenever next year, okay, this year AIMT is over, but whenever next year if someone sees, right, some aspirant see, then they will get to know that okay, these AIMTs are actually good, these AIMTs are very much worth attempting. So don't do it forcefully, but I hope if you are liking, then please do it. Okay, because it really motivates us. So just put just one word. I'm not asking you to write a long paragraph, just one line, one word, whatever you feel, right? If you feel a long paragraph you should be writing, you can write it. It will be very much nice, but whatever you feel, you can just do it. Okay, so that is all for this particular session. Thank you so much. Okay, thank you everyone. So you're taking the class for full length test for DA. Yes. So for full length, we will be having the video solutions. All the AIMTs will be having the video solutions. All the AIMTs. Thank you everyone. Take care. And not just video solution, it will be having detailed video solution. Okay. It will be having detailed video solution, not just video solution. I mean, there's a difference as you can see here. Okay. So we always have detailed video solution.